Hello everyone, welcome to In 5 Minutes. In this video we are going to see the next type of beta function, that is type 2. So in type 1 we used our formula of beta of m comma n as integration 0 to 1 x raised to m minus 1 into 1 minus x the whole raised to n minus 1 into dx. So in this case, in type 1 we have the limit from 0 to 1, but in type 2 we will have the limits from 0 to infinity. In type 1 we used to make any given equation in this format and we apply the property of beta of m comma n. In this, our equation should be in this form: x raised to m minus 1 upon 1 plus x the whole raised to m plus n into dx. When our equation is in this form and our limits are from 0 to infinity, then this is also equal to beta of m comma n. Okay, so any given equation we have to represent that equation in this form so that we can apply the formulas of beta of m comma n. This will be more clear when we see the problem on this type. So this is our question: solve this. So in this case, if you observe, we have limits from 0 to infinity. When we have limits from 0 to infinity, that means it is of the type 2. Okay, remember this. So now our beta of m comma n is given by integration 0 to infinity x raised to m minus 1 upon 1 plus x the whole raised to m plus n into dx. So we have to represent this equation in this format. So observe this, numerator is matching. Okay, we have the numerator x raised to something, so here also we have x raised to something. In the denominator we want 1 plus x term, but here we have 1 plus x square. Instead of x square we want only single variable whose power is 1, so we will substitute x square equal to some other variable whose power is 1. So we substitute x square equal to t, then x will be t raised to half, then dx will be half t raised to minus half dt. Okay, since we are changing the variable, our limits of integration will also get changed. Here we write the initial variable is x and the new variable is t. X is going from 0 to infinity. When we put x equal to 0 in this equation, we get t equal to 0. When we put x equal to infinity, we also get t equal to infinity. So now our new integration is integration of 0 to infinity x raised to 6. We are replacing x by t raised to half. So t raised to half the whole raised to 6 upon 1 plus x square. 1 plus x square is nothing but t. So 1 plus t the whole raised to 6 into dx. Dx is nothing but this term, that is half t raised to minus half dt. 1 upon 2 is constant, so we can take it out of the integration sign. Integration 0 to infinity. T raised to half the whole raised to 6 can be represented as t raised to 6 by 2. So 2 1s are 2, 2 3s are 6, by get t cube. We will combine this t cube and t raised to minus half. We will get t cube into t raised to minus half, which is equal to t raised to 3 minus half. So this will be equal to t raised to 3 2s are 6 minus 1, 5 upon 2. So this term and this term is nothing but t raised to 5 by 2, and the denominator will remain as it is, the whole raised to 6 into dt.